Hey Global Impact students, this is Mr. Ellinger. This lesson is on solving two-step equations. Our learning target for the lesson, we want to be able to solve two-step equations in one variable. Essential understanding for the lesson is that equivalent equations are equations that have the same solutions. The solution of a two-step equation can be found using the properties of equality and inverse operations to form a series of simpler equations. Also, the properties of equality can be used repeatedly to isolate the variable. Background information: there's more than one way to solve two-step equations. However, you will find it beneficial to choose to undo operations in the reverse order of the order of operations. For example, in the expression 2x plus 3, x is first multiplied by 2, then 3 is added. Reversing the order of operations means first subtracting 3 from each side of the equation, then dividing by 2. Okay, so just to discuss this again, to solve two-step equations, you can use the properties of equality and inverse operations to form a series of simpler equivalent equations. You can use the properties of equality repeatedly to isolate the variable. A two-step equation like the one shown below involves two operations. This equation involves multiplication and addition. To solve a two-step equation, identify the operations and undo them using inverse operations. You can undo the operations in the reverse order of the order of operations. For example, to solve 2x plus 3 equals 15, you can use subtraction first to undo the addition, then use division to undo the multiplication, and that will isolate your variable. Okay, so here we have three examples. Our first example, 2x plus 2 equals 14. Let's go ahead and divide our equation into two halves, two sides. So here's our variable x that we're trying to isolate. We have 6 times x plus 2. So we're going to do our addition and subtraction parts first. So we're going to subtract 2 from both sides, do the opposite of what the equation says. So when we subtract 2 from the left, we create a 0 here. That leaves 6x on the left side. 14 minus 2 is 12. So we have 12 on the right side. Now we have a simpler, smaller equation with just one term on one side and one term on the other side. We're trying to isolate x. This says 6x or 6 times x. The opposite of times is to divide. So we would divide both sides by 6. 6 divided by 6 is 1, so that gives us 1x, just x. 12 divided by 6 is 2. So we have a solution of x equals 2. Remember, you can always check your solutions, and it's a good habit to get into. Real quick, I would just put 2 in for x in the original equation, see if I get a true statement. 6 times 2 is 12. So I have 12 plus 2 on the left. 12 plus 2 I know is 14. 14 equals 14. So I know that I have the correct solution. And to an equation like these, there is only one solution. Alright, let's solve this one. 5 equals t divided by 2 minus 3. And again, we'll go ahead and draw a line down here to divide our workspace into two parts or two halves. Here's our variable. Our variable is being divided by 2, and then we're subtracting 3 from that. So we will go ahead and add our 3 first. Add 3 to both sides. Minus 3 and a plus 3, that gives us 0. That's why we're doing this. So on the right side of our equation, we have t over 2. The left side, we have 5 plus 3, which is 8. We want t by itself. We want to isolate t. T is being divided by 2, so we will multiply by 2. And we will do this to both sides. The 2's here, remember the reason we do this, the 2's cancel each other out, if you will. They give us a coefficient on t of 1. 2 times 8 is 16. 16 equals t. T is isolated, so our solution is t equals 16. And I could probably use, I can write this out to check my solution. A lot of these I can actually probably just use some mental math. If I take 16 here, 16 divided by 2 is 8. 8 minus 3 is 5. That's what it should equal. So I know I've got the right solution. Here's our third example. 6 equals x minus 2. All that divided by 4. So just a little different looking problem here. X is in the numerator of this fraction here. So if x is in the numerator of a fraction, our first goal would be to get rid of the fraction. Since all of this is being divided by 4, we'll do the opposite of divide by 4. We will multiply by 4 on both sides. The left side, 4 times 6 is 24. And on the right side, dividing by 4 and multiplying by 4, those are inverse operations. They undo one another. So essentially, remember, they cancel each other out. So what's left is just this numerator part, which is x minus 2. And then to solve x minus 2, I'm just going to add 2 to both sides. So I get 26 equals x. That's my solution. And using mental math, I could go back here and check and see if this is in fact correct. 26 minus 2 is 24. 24 divided by 4 is 6. That's the right solution. Okay, and here I just wanted to put an example on here of the justification of each step. You know, when we solve these equations, we are using the properties that we looked at in Unit 1 to solve these equations. And we're not going to write out proof right now, but this is what's called a mathematical proof. And I may ask you from time to time, what property are we using? Are we allowed to do this? And the reason that we're doing what we're doing and the reason that we can do what we're doing is because of these properties. So if I start off in my original equation was negative t plus 8 equals 3. I'm trying to isolate t. 8 is being added to t, so I'll subtract 8 from both sides. So I get negative t plus 8 minus 8 equals 3 minus 8 by the subtraction property of equality. Simplifying that, I get a negative t on the left side. I get a negative 5 on the right side. We're just using subtraction to simplify. That would be the reason for this, to go from this equation down to this equation. The next equation, I just take negative t and rewrite it as negative 1t equals negative 5 by the multiplicative property of negative 1. Sometimes when we get this negative t here, we're not sure what to do, but we just need to remember that negative t is the same as negative 1t. We don't want negative 1 in front of t, we want 1. So we have to then divide through by negative 1 by the division property of equality, which gives us a final result of t equals 5. The variable t is isolated, it has a coefficient of 1, it is solved. And that last step is the justification of the reasoning is we use division to simplify. So we could, if we wanted to, write out every single step and the reasoning for every single step if we had to. Hope you have a great day.